Hey everyone, welcome back to another episode where today I'm going to show you how to run some popular programs on OpenShift without compromising platform security or application security. So, as always, let's get into it by defining the problem. And it's not really a problem, it's just kind of an issue. And the issue is that OpenShift is secure by default. Kind of an odd thing to say that that's an issue, but OpenShift was designed from day one for multi-tenancy. So security is a feature, not an option. You're probably going to have multiple deployments on an OpenShift cluster, and we want to ensure that one application running in one project namespace doesn't compromise either resources or security for applications running in another. So, many Kubernetes systems are running containers as root by default, which is not a good thing. Some people that are just getting started with Kubernetes don't understand why that's an issue. And again, because of if you're going to have multiple applications or multiple projects, you don't want one project compromising another. So you can lower OpenShift security constraints, and I have seen that done. It's not a good idea. You want to modify the application to work with the constraints. So you could do it, but why would you want to? It's better to modify either the deployments or the container so that it's working with better security. So let's talk about how to keep the apps and the platform secure so there were no compromises. As I noted, most Kubernetes clusters are dangerously permissive by default. I've seen this all too many times with non-OpenShift systems where the deployments, the developers don't want to spend the time, or the application teams don't want to spend the time working with those security context constraints to get the application running in a fashion that obeys the OpenShift's inherent security. Um, but ultimately, we have to reduce the risk of privilege escalation attacks, especially in a multi-tenant system like a Kubernetes. And if a developer or an application team pushes back on you and says, "Hey, we really need this application to run as root," push back and find out what it is that they're trying to do or why they think that they need the container needs those privileges. Because 9 times out of 10, they actually 99 times out of 100, they don't. And for that one time that they do, we probably need to rethink our deployment strategy. So the solution here is to work with security and not against it. We can typically modify something like a Helm chart with a values file that works with OpenShift's security context constraint, or SCC. So in this case, we're going to tell for this RocketChat program, we're going to tell the Helm chart not to specify explicit user IDs or group IDs that would conflict with OpenShift's security model. Now, the security context constraints still enforces those important security boundaries, such as ensuring that the pods still run as non-root users, pods still can't access the host resources, pods are still isolated from each other, and the containers themselves have limited capabilities. It's in essence, we just want OpenShift to do what it's designed to do, which is to run the applications in a secure manner that doesn't compromise the security of any other applications running on the system. So the example deployment that I picked out is a kind of a favorite of mine. It's something that I've worked with over the years. It's called RocketChat. It's a very popular open source chat system. It's probably an alternative to something like Slack and Teams is very Slack and Teams like. However, we need to make some modifications to get it to run in OpenShift. And I'm going to walk you through that Helm deployment today and show you how you can do something like that for RocketChat. And then, of course, other maybe commercial vendors that may only provide a Helm chart for deployments and need some modification to get going in OpenShift. So, with that, demo time. I have posted step by step instructions on GitHub, and I'm going to show you how to deploy this in Red Hat's free developer sandbox, which you can get you get yourself a free account at developers.redhat.com today, and we're going to have some fun. All right, let's get into it.
Okay, so log into the free Red Hat Developer Sandbox, and please make a special note of the URL. Let's copy the login command, and we're going to paste that entire line into our terminal. Okay, so using the OC command line tool, paste that command, and then switch to the default project. You can only get one, and that's fine. And then we're going to switch to the git clone of this project here, and we're going to open up the values file. So change the host name and the database password for MongoDB. Those are the only two values you need to change. Okay, and then let's just make sure that we're all good with the Helm repo update, that we've got the official Helm repo, and now we're ready to deploy. So we're going to run the Helm install command, specifying the values file that we just modified here. And that's it. So now we can use the OC command to list the pods we're going to watch here, and we're going to watch the database and the application deploy. And don't worry if you see any errors or anything like that. You know, that will happen sometimes in the deployment. Yes, there we go. Let's make a note of the URL. So we have that. We're going to go to that URL once the application is deployed. And this process should just take a few minutes. And as I said, if you see any errors like that, don't worry about it. You can switch back to the console and you can watch the deployment happen visually as well. Solid blue means that the application has deployed, so Mongo is ready. We're still waiting for RocketChat here, and then we'll click that little arrow out, and look at that. Our RocketChat instance is ready to go. We just need to register, and we're good. Thank you for watching. I hope this was helpful.